we are here with Andres Bracho, a tNav support engineer, reservoir engineer by background, if I get that correctly, Andres.
That's
Thanks
right.
for coming on, man. Appreciate it. Good to see you. And tell us, what are we going to see today?
Well, firstly, thanks very much for having me. It's kind of an exciting topic and something that, I've always kind of had interest on. So, it's pretty cool to be here. Thanks for the opportunity. Today, I thought I'd show you a bit of the latest on agentic AI in terms of reservoir simulation, particularly tNavigator, obviously being a part of RFD. All the examples and stuff that I've made use kind of the tNavigator tools to, and in this case, I'm using Claude as an AI, a bit of a sneak peek, but to drive a few of cool examples and stories that might come in useful for other engineers in the field. So yeah, we've got a few examples that I can show and explain a little bit how that's set up.
Great. I'm excited. Being a tNav power user, man, I think a lot of people are going to get a lot of value out of this. So take it away,
That's
share your screen, and let's dive into it.
sure thing. I'll start. Great. Yeah. So first things first. As you say, you're a tNav power user. Some of your audience, I'm sure, will be familiar with tNav. Some might not. So just as an introduction, this is kind of the main tool that I've been using for this sort of AI and agentic AI use in reservoir simulation. This is the tNav launcher, gives you access to a lot of the different toolkits that are available within the suite. Now, I wanted to talk about, firstly, just don't want to assume kind of knowledge from anyone. So I wanted to speak firstly about the true power and the introduction to agentic AI. So everyone is familiar with, well, a lot of people are familiar with AI in terms of LLMs and all the different, flagship models that are available out there. People are familiar with ChatGPT, Claude, Gemini. Now, these things, as people know, they're super useful. They're really, really good at doing, giving you an answer. Sometimes too good at giving you, false information. So that's one of those things that is quite important, particularly when you're working with to putting tools together to know essentially how to assess. And the thing that I really want to drive through kind of this chat is a little bit of the importance of having a human in the mix, because all of this is super useful and super interesting, but it doesn't go very far unless you have kind of a human, an engineer, a geologist, someone involved that knows what's happening, because it's very, very easy to get into tangents. So first things first, LLMs, everyone's familiar with them. What you do with ChatGPT, with Claude, you ask it a question. It's kind of just based on is predictive text, essentially. It gives you an answer based on the most probable sort of what token is most probable after the other, and it just gives you an answer. Now, people are familiar with that. Some people are not as familiar with the term agentic AI. Agentic AI is essentially it's utilizes that LLM, that ChatGPT, that Claude, as a brain of the operation. Is still using that to reproduce an answer, but you're essentially giving it kind of arms and legs. You're giving it the ability to not just give you the answer, but instead of you asking a question, you ask it a task. So you tell it, do something for me. And this term agentic AI, there's I see it is not sort of how I'd say it's known properly, but the way I see it, agentic AI, there's two main things. Firstly, it's the looping mechanism. So it goes, you ask it a task, it tries something. If it doesn't work, it goes and tries a different method. It kind of this sort of cycle, this sort of looping method is quite a powerful thing that agentic AI brings. The other thing that it exposes is the agentic AI. Main difference between LLMs is also the fact that you are actually giving it tools. You're giving it those arms, those legs to be able to do the action that you wanna do. So you're giving it access to things like APIs. You're giving it access to things like plugins and tools. And one of the main important things into I've set up this, and how most applications now or tools now talk to AI agents like Claude and ChatGPT, is this three-word letter that is fairly new, so not a lot of people sort of are familiar with it, which is called MCP. MCP stands for Model Context Protocol. Now, you can think of MCP essentially as just a piping, a connector between a tool and a large language model or an agent. So it is a standard, it's an open format. It was actually developed by the developers of Claude, Anthropic, but it's an open format, and what it does is just details how that connection between the AI agent and a particular tool, in this case tNavigator, how that works. It exposes some tools, and it has some documentation telling it, okay, what are these tools, how do we use them, and how do we call them, and so on. So in tNav, we are lucky enough that we got some really cool and kind of at the forefront developers, and they saw this coming, and they developed a MCP server, which is that main connection that I'm talking about, that MCP server embedded within tNavigator. So the first thing I want to show you is how simple it is to set up a kind of Claude or any other agent AI connection into tNav. So within tNav, now in the newest version, which is 26.2, there's this option, which is when we go to the settings, that talks about an MCP server. All we have to do is when we open tNav, just click on Start the MCP server. I already started, so that's why it says stop on my case, and it starts spinning that MCP server that's a Claude or any other AI can connect to. Now, if it's the first time that you're doing the connection, it is usually setting up the MCP connection is a one-time thing. You register the MCP server, and it stays in memory. So later on, when you come back, you can close your AI systems, your agent AI, come back to it, and that MCP, once it's registered once, it will always be there when you start a new session. So this is a setup that you only do once. To do the setup, all you have to do is just in plain English. We have a little helper thing here, which is a configuration of local MCP server that comes within tNav. So it copies it to a text file. And if I open here, let me just open a new file. I just copy some text of where that MCP server is. And all you need to do is, in plain English, you go to Claude. Now, in this case, I'm using the Claude desktop app, but you go into Claude or whichever agent you have, and you essentially, in plain English, tell it, I am trying to set up a MCP server, so trying to set up an MCP server for tNavigator. And then you can give it the information. Here is an example of the setup from tNav. So you can paste now the thing, and Claude will go and actually go and register this MCP. It will read through what it needs to read, and it will establish that connection. So it's as simple as that. So the actual connection is quite light, it's quite easy, and it exposes a few tools. Tools are essentially how Claude is going to do tasks and interact with tNavigator. It opens a tool to open a project, and then opens a tool to run Python from within tNavigator to do things, which is what kind of I want to show you as well. So I'm not going to run this just because I've already registered my MCP, but in this case, yeah, it's as simple as that. When it comes to working with AI agents, lots of people have different preferences. I know a lot of people use, this is Claude Code, by the way. It's separate to their chat. Chat is essentially just their LLM. Code is more of the agentic Claude version. And I'm using their own Anthropic desktop version. Lots of people use things like Cursor or just simply the terminal. It just depends on what people are kind of familiar or comfortable with. There's lots of advantages to each one of them. I like this one just because it tracks, for those of you familiar with how agents and Claude specifically works, it works with context, which is kind of what keeps in memory from a particular session. This one, the desktop version tracks context and how full it is. So you have a limit on how many words or how many tokens you can use within one session. And this keeps track of how many of that live. It also has lots of different tools and connections, and it really has a lot of kind of features that I quite like, and I find it quite easy to work with.
You don't
So,
have to do it necessarily from within Claude Code. You could do it from Claude Chat or Cowork, for example.
yes. Well, I'm not sure from chat, because chat is not set up for proper agentic work. As far as I'm aware, there might be some functionality that I'm not familiar with. But even if, let's say you start from chat, right? And this is kind of what I did here. I actually, for planning, I actually asked Claude Chat how to best set this up. And it actually pointed me to use Claude Code, because you're going to have to work with lots of files, and you're going to have to register things like MCPs and just stuff like that. So I think inevitably chat might point you to code, but I mean, the all the MCP is doing is exposing tNavigator. Also, we have the luck or the fortune that it has an API, a Python API. So it's a connector. That's how you can interact with tNavigator through Python language. Now that is kind of the main arm or the main toolkit that the MCP server uses to provide that connection between another program, in this case the agent, and tNav. So you could, the reason I brought this up is you could theoretically use chat to essentially build you some Python code that interacts with the tNavigator API, and then run, you yourself manually run that code that Claude Chat gives you. So I have here a few examples that I thought it might be useful to show on how this works, and show some maybe useful stuff for the day-to-day engineer geologist. So I collated a couple of examples. One thing that I really want to sort of highlight here is that there's been quite a lot of examples put out there on really impressive stuff, and it looks really flashy. And this Claude can, for example, drive, as you'll see in one of my examples. It can drive the tNavigator interface. It can move things around. It can pretty much do what a human can. And those are things that are pretty flashy. However, in my personal perspective, the best use of AI and the best use of this agentic sort of integration is the very tedious, very time-consuming things that us humans take ages, and AI is very suitable for. This is not particularly the most flashy thing. Is usually not the thing that you look at on the screen and say, wow, that's amazing. But it's a thing that if you really think about it, it just saves you so much time, and it allows you to focus on the things that you really want to focus on. So I prepared a couple of examples that may not be as flashy, but I found to be particularly useful when it comes down to working on a day-to-day basis. So I have a little run sheet here that I here. Perfect. So I'll pull up Claude and the run sheet side by side. So I have a couple of examples here. A couple of them I've worked out before. And what I've done is I've worked them out before. It spit some output just to check that things were working. And then I deleted the output. So all we're going to reuse from previous things are if there's any code that was developed by Claude that was able to do a particular action, so any Python script that it built, I am building a little library of scripts. So one can build its own library, and what you can tell it to when you give it a prompt is you can tell it to, okay, if there's any code that you might find useful from the library, reuse this instead of making some new code. This accelerates the process, and if it's something that's verified, if it's a code that you verified, then it very much kind of standardizes and makes your process a bit more robust. And the first one is one that I'm quite familiar with, working a lot as a support engineer, which is the you get handed a project, you get handed a model, you have no idea what the model is, you have no idea sort of what's in that model. So before you even touch it, one of the cool things that I found that you can do with this is you can ask it to read the model and give you a bit of a summary of what's happening. So just to show you how easy it is, and then we'll talk through it, because it does, well, one thing, as you'll see in a second, this process takes some time. So let's just copy this. This is the prompt. So this is what we're feeding. Essentially, this is what you would feed a large language model. So a chat, you interact with code in a similar way, except you give it more of a task. So the task that I have, if we just read it verbatim really quickly, is, let's say, the scenario I've just described. So I've just been handed a project and there's no documentation. Here's where the project is. Now open it. I don't know what field it is or anything about it. So please read the model and give me a briefing. Tell me the area, the location, tell me how many wells, the grid size, tell me the fluid type and the simulation time span. And then most importantly, if you find, as you're reading through this model, you find anything unusual or any gotchas hiding in that, then I want to know before I start my actual work as an engineer. So dig into the project, do whatever you need to do, just try and find whatever information you can before I go into this blindly. So this is pretty cool. So
Before you hit enter there, before you hit enter, mate, two things. So one is you don't need to have tNav open. The connector could open it. Is that correct?
That's a great question. So you need to have the tNav launcher opened because for this MCP server so for this MCP, which is a connection again between the agent and the tNav, you need to actually have tNav running the MCP server. So it's two sides of MCP: is the client, and then the server. The server is what's on the tNav side, and the client is what the Claude sees. Now,
Yeah.
you need to have the server spun up for this connection to work. So you don't need to have the project open, but you do need to have the launcher open, and you need to do what I said before, which is go into the AI server and launch the MCP server.
But not every single time. So you do it once, or every time you open the launcher, you need to go here.
Every time you open the launcher, you go here.
Okay.
But it's you can have several sessions running concurrently. So you can have an agent looking at one task and another agent looking at another task at the same time with the same launcher. So you don't need to do it for every task. You just need to do it once when you first open tNav.
You just launch the server. Yeah. Okay. Yeah. And the other question I had there, back to that tNav connector folder you see above the chat box. That's the folder, right? But in
That's the
terms
folder.
of the connector to, the MCP server itself, you have not set tNav in the prompt. You just gave it the path to the file. But do you have to tell it here in the chat instance that use the MCP where it says auto under or the plus sign? You don't have to indicate there that you're going to be using the tNav connector.
No, that's a good question. So when you first do that MCP connection, that registration, that is a one-time thing again, which registers an MCP server, and then every time you start Claude or you start a new session, it checks which MCP servers are available to it, and it knows. So it's once you do it once, every other subsequent fresh session, when you start a fresh session or when you restart a session, it checks which MCP tools are available, and the connection is already established. So a way of seeing what you've got available is just to type -mcp, and it gives you a bunch of different MCPs that are connected to it. Now,
the issue that I found, sorry to interrupt you, but the issue that I
yeah.
found in other instances with other MCP connections
Mm-hmm.
is that sometimes you prompt something and Claude tries to give you an answer without using that connection. So unless I tell it to specifically use that specific connection that I want to the answer to come from, it
Hmm.
might not use it.
Hmm. That's an excellent point, and yes, that is something that can happen and does happen a lot. And for that, so in my case, I never tell it to use the MCP explicitly. Whenever I ask it to do something in TNAV, it's going to go and check that MCP. And the reason for that is two things. Firstly, there's persistent memory. So Claude itself has a markdown file somewhere along its own file. So it's not part of this tNav connector folder, but is rather part of its own files where it's a memory file. And it's a persistent memory. And it has knowledge of the important things that we've found, the learnings that we've found over the past few sessions that we've done. So what that memory would have had is that everything that I've done with tNav has been using this MCP. So it knows that it's going to use, every time I ask something about tNav, in the past, it's used the tNav MCP, so I'm going to use it again. It's repeatable.
Yeah.
The other thing is, as you're working with this sort of stuff, it's good practice to generate what we call a knowledge base. It's another markdown file. It's another documentation, which it's a main index that tells Claude kind of the best practices, what to do when a particular question arises. And one of the most important things as well is the pitfalls. So what not to do, what things that we've tried before that did not work, so that it doesn't go through those and commit the same mistakes. So this knowledge base is something that you build as you work through with Claude, and you ask it to document these things and report it to knowledge base. All you have to do, again, like all the things that we do with these agents, is you ask it in plain English, like, okay, add your learnings that you've done from this session to the knowledge base, and it writes it to a markdown file, which is here. So we have a folder that this is something that got created by Claude, by me asking it to create it, and it has a main knowledge base with the main README, and it points to all other aspects of what happens when the one I mentioned before is pitfalls, which is really important. It's like what it's tried, it's determined that it doesn't really work, and it spent a lot of wasted time on it. So it's really important to document these things so that it doesn't commit the same mistakes. So to go back to your question, when I never really explicitly asked it to use the tNav NCP. I, at some point when I was working through it, I did probably mention in plain English, is like, whenever I ask you to do something in tNav, use the MCP connection, and it committed it to memory, and it also committed it to the knowledge base.
Are you actively asking manually each individual time you feel like something has been learned and it's important to record in the knowledge base? Or do you already have a general instruction at the project level or at the folder level to do your own recording
Mhm.
of all the learnings in each individual instance?
That's a good question. And for this particular project, I have several instances of the tNav connector. For this particular one, I'm doing it manually, just for the reason that I haven't had um, I was working and drafting a few things, so I didn't want everything to go into it. But the general idea and the better approach, in my opinion, and something that I've used in other projects, is, as you just said, a more scheduled or more methodical, automatic way of whenever you do something right, and I said is right, automatically document it to the knowledge base. And again, that's something that you just ask it in plain English. You just say, please, every time you can have even a keyword, you're saying, okay, I'm happy with this, and every time I say I'm happy with this, document it to the knowledge base. So you just ask it in plain English, it loads into its persistent memory, and then every time you say that keyword, or even every time something happens, you can set a trigger, then it documents that, which is, I would say, probably better practice than doing it manually. The other thing that's a really good practice, which I'm not doing here either, so I'm preaching something I'm not doing here, but I've done in other projects, is having this as in a Git repository, so that you have, let's say you have a knowledge base, or you have some code, and you're working on that code, and you have several versions of that code. so that you have all different changes to that code well documented, and you can at any point roll back to any of those things. So that's really good practice, something that I would probably recommend doing. Again, not doing it here, but I've done for other projects, and it's generally a really good tool to have. Sometimes you're like, I made a change and it's broken everything, and I can't go back to it. So that's very important.
All right,
Good.
let's see what that prompt does.
Let's see. I don't know if I still have it copied. Let's see. Perfect. Okay. So all I done is grab that prompt that I showed you, and I copied and pasted it. So let's see what it does. So this is a fresh session. This has nothing. We still haven't fed it anything. So let's see. One of the really cool things about this thing is that it shows you it's working out. So it shows you what it's doing, and it shows you its process. It shows you if there's any errors, what it's doing, and it shows you kind of the outputs as it's spitting them out. So as you can see here, well, what does it say? I'll dig into the model via the tNavigator's API and the raw source data folder on the disk. Let me start both threads in parallel. Then it runs a command, and I don't know if you noticed there, flash, but it's actually opening a tNavigator window to drive it. So once it loads, I'll show you on my screen. Great. So I have it here. Let me put it here. So it loaded a tNav window. Now, while it's running a particular Python codes, sometimes most times you can work through the model. So this is a Volve dataset. It's an open dataset that is used for a lot of examples. So let's just go and visualize what we got here. So we got a bunch of wells in there, and if we look, it's a simple model, but it's very useful because it has quite a lot of features that are useful for demos and for showing things. So one thing that you'll see, you might see as Claude is working. So it tells you what it's doing. It also, because it's using the MCP server and the tNavigator API, everything that Claude does through tNavigator is displayed here in the log file. So it tells you, okay, it needs to request some license features and whatnot. So one of the really powerful things of this integration is that Claude tries something, a lot of times it hits errors because it tries something that maybe it's the first time it's doing it, or maybe the route that it assumed to take is not the right one. So when it finds an error, it reads what the error message from the API is, and that's one of the things of the NCP that protocol is really good for. It documents how, not only how the agent communicates with the tool, but how the tool communicates with the agent and spits out some outputs. So Claude is reading, as this is working through, Claude is reading what's outputted from the tNav window, from the log. It's making, okay, I made a mistake, there's an error here, and then revising or trying something different. So now it's doing some more stuff. So let me get started with the API snippets, read the fluid and PVT source. And it's going to ultimately, at the end of this, give us some sort of document with some summary of what the model represents and what I've asked it to do.
In this interaction with tNav, potentially you could drive this with natural language in Claude for all the specific individual tasks you might be able to do yourself in tNav. So if, for example, you want to do something that you can't quite remember how to go about it in the
Mhm.
tNav app, let's say you want to display a property in the 3D grid, filtering by another property, and you don't quite remember how to do that, can you just prompt that away in natural language and then watch in real time how this task is performed?
Yeah, absolutely, and that's kind of one of the big powers of this as well. Just to show you how it works as well. So within the MCP server exposes what we call tools, which is particular functions that the agent can use to interact with tNav. One of those tools is actually, rather than it reading the entire documentation, which is not, it will take a long time because it's like thousands of pages of tNav documentation, and to make sense of all that takes time. So rather than just tell it these are the manuals, read them. One of the tools exposed within the MCP is actually a documentation tool, which is a essentially tool that you give. The arguments are a question, and it points you to the parts of the documentation that has that information in it. So it's similar to what I showed you before. The tNavigator AI assistant is doing. So it's kind of like a bit of RAG.
So I presume
Retrieval.
that is just a vectorized database already with a RAG pipeline behind the scenes, and this tool only searches that vector database for the
Yeah,
right
so
embedding.
the tool, it's essentially a search engine within the documentation.
Yeah,
It doesn't have to read
yeah,
the entire documentation and then make its own assessments every time. It just asks using that tool. It just says, okay, how can I do this? Then the tool returns to Claude. Okay, this is how you do it, or this is where you can find it. Then with that information, Claude goes and queries the API or creates a Python code to then do the task using the information that it got from that
yeah, got it.
application.
But just curious, is that documentation tool is just the documentation index, and this is just a search function, or is it a proper RAG with an embedding vector database?
That's a good question. To be honest, I'm not 100% sure on how it's structured, but we don't really, that tool that is exposed, we don't interact with it at all. Claude itself decides when it doesn't know something or when it hasn't done something before. It decides when to use that specific tool. So in terms of interaction, the user never really sees it.
Yeah,
It's more of how it retrieves that information.
yeah,
And I do think it's a RAG style tool, but
yeah.
don't want to say with 100% certainty, as I'm not sure.
I mean, I'm already
Um,
getting so many ideas as to how to use this connection to to run TNAV tasks and workflows.
it's super useful for
Man,
that. It's I think where it really shines, at least for me, it's a couple of things. I see it kind of like as a tier, right? Tiered system. The first thing is asking it, as you well said, how to do a particular thing. Maybe I forgot, maybe I haven't done it before. Show me where the button is. Tell me where things are, or do it for me so I can learn where it is. The second tier is the menial task, which is, I have another example here, but this is one of them. Like, you have a data deck, you don't want to read through the whole thing. Give me some summary so I at least have some information before I go in. So things that are tedious, things that takes us a lot of time, but for a computer it just takes a few minutes and it knows it can give you some data. The third thing, uh, the third tier that I see really useful is to some pattern recognition. So we can use tNav, what we can use is this agentic tNav workflows to do things like the things that we're bad at. Like humans are really good at kind of deep understanding and focusing on one thing. But when it comes to lots of different factors and seeing how they fit together, that can be quite a challenge. Whereas for an AI model, finding those patterns and finding
mm,
these things is quite easy. So we have a few examples where we've used this sort of agentic AI integration to do history matching. So for when the history matching is really complex and none of your algorithms are working, you can put a layer of AI on top. You can say, look, I've ran all these models, take all this information in and see if there's any patterns that I've missed that I can try. So it's not taking us out of the equation. It's not taking your engineer out of the equation. All you're telling is, like, look at all this data, give me some patterns that I can then use to do my work and do some further analysis or further matching or further things. So we have actually a few users, a few clients use that type of AI integration before. So I think here it's finished. You can see it probably took, I'm not sure, probably around 5-10 minutes. It's looked at a lot of stuff, and it gave us it's given us a briefing. So giving us what we asked it, the field, the size, the fluid. Now, what I can do for this, because one of the cool things about this as well is that not only does the agent does the loops and does the task, you can then ask it subsequent questions and subsequent tasks to do with this. So I can then say, okay, please put all these learnings into nicely formatted XML file. All right. Nice format. Let's go Markdown file. No, let's go PDF. So it can go, uses all its tools. It knows what it's used, learn from here, and it uses some inbuilt skills like a PDF skill to then create a PDF, and it's going to open a little report for us,
Yeah.
which we'll see in just a minute. So maybe whilst that is running, you see he's building. Let's try another example as well. So I have another example here, which is a little bit more convoluted, and it's another thing that I see some users and some people kind of don't like to do, and it's the meaniest task that nobody really likes, which is the case when you get some new production data, new history. You have a model, the model hasn't been updated in years. You get some new data, you're given a task, you need to update the model. And obviously the data is never going to be nicely formatted. The data is always going to be completely off. It's going to be in different formats. It's going to be just a mess. And the first step is to make sense of the mess. Second step is to put it all in a format that you can import, and then the third step is to actually use that data. So this is another thing that I think AI really shines in, which is the menial task of data formatting, finding some kind of some recognition, some patterns in the data, and then putting it all together and doing something with it. So in this example, the prompt is a little bit long, but the gist of it is we have this, again, the same Volve model. Open it and work with it. Now, I have all my data I collated into this folder called raw history, and it's got different formats. It's even got mixed units. It's something where you never like converting units. 6 different ways of writing one well name. One might have hyphens, the other might be underscores. You need to consolidate them all together. It's hard to do by hand. So I'm telling it, merge it all into one data set, turn the operators into well events, import the clean history on top of my model, so do that for me as well, and then create a restart or a forecast model on top of the base results that I already have, the old model that I have, and leave it for me so that I can analyze it, flag anything that you've sort of found that it might be incorrect, or don't make any assumptions, just give me what you've done and anything that that you think that might be incorrect. So that's the gist of it. So there's another example. This one obviously will take a little bit longer, but what we can do is while this one's running, I'm gonna, just to avoid any confusions, I'm gonna run the current tNav project because we're running essentially the same model. Great, and I'm gonna start a new session of Claude. So it's a fresh session. Again, it has nothing in it. All it has is this persistent memory from other sessions and so on, but it doesn't have any context for this session so far. So I just copy paste that, and let's make that run. Then while that runs, we will go back to our original one, and we'll see what it's doing. So this is something I actually hadn't asked it before. So even though it has a skill of creating the PDF, it's probably something that still needs to discover. So when you first do something with this integration, it's going to take a bit of extra time usually because it has to figure out how data fits with each other and what it does. But you can see it now created this PDF file for me. And it's a little summary of what I asked it to do. So give me a rundown sheet. So it tells me the location, the reservoir, the fluid model, what the grid is, the wells, time span, runtime, and the important thing, the thing that it's easy to miss, because this you can extract. It takes a bit of time, but you can extract. But the thing that is easy to miss is like, okay, consolidating all that data together. So This is got just before you start. Licensing needs a full bundle. That's more about tNavigator and like what you're running. So this is not too relevant to the model itself. Project auto. So okay, there's a duplicate well name, which we might have missed if we try and like just open the model and make sense of it. It's heavily faulted, so that's important to know. Endpoint scaling is active, so something that's also easy to miss. We have some results in there. That's great to know. And yes, some briefing was already in there. So it gives you a really cool sort of summary and really useful information, really, that you can utilize for your projects. So I think this is done. Let's see what it's done. So we have, let's see. So in our original model, let's read from the prompt. Let me just go back to the prompt. Let's read it here. I think we had history. The original model only had till 2013. So let's see if it's done it. Sorry, I think I should have put it up while we were talking, but let's see if it's done it. So the history data within a TNAV project usually lives within here. So let's see, wells data. I think these were the original ones. So let's see, well, production table monthly. It goes until 2013. Then it has this this table, well production table, the update. It goes from 2014 to 2016, so it's loaded the data. Just to check, let's see, I'm just gonna go see, just to show as well the audience, the type of data that we were working with. We have raw history. Okay, so we had, as you can see, a lot of different formats. We have some text, we have some Excel files, some CSV. So let's see quickly. So we have a text file that has, okay, that's pretty standard. That's pretty good. Units are in field. I think our project is actually metric, so it must have handled that conversion. Let's also see what other data we have. We have a monthly summary. What would that be? So we have, okay, an Excel file with some oil, and this is now in metric as well. So regardless of some conversion had to be done, and this is for one particular well. I think it has a different well convention as well, naming convention. Let's see what else. We have an operations log. I think this is more of kind of like a journal. So you can see it's mostly text. It's not even like a numbers that we can load into a model. We also had, let's see, this is a CSV file. I think it's just more history. Yeah, with semicolons, which is an interesting choice, and then some text file as well, some water injection export, which I assume is just just some stuff for the injector wells for injection rates in meters cubed per hour and VHP. So you can see lots of different unit systems, different formats, different things. So the first thing that we asked for it was to create a kind of clean record of the data. So let's see here, see what it's done. It's yeah, oh, that looks a lot nicer. So it puts them all on the same, a nice name convention, puts it on its particular relevant date, and it puts it on the same standardized format, which is great. The other thing I asked it to do on that prompt is to create a quality report to tell me what it's done and if there's anything to worry about. So let's see what it did. So it created this this table for me, this markdown file. It tells me this particular file, it was pretty bad. The oil water looks swapped. So we actually had some units that actually it inferred on its own that the units weren't reliable. And it did something, but it did tell me about it. So that's one of the things that is really important about this. When you're setting this up, when you're first setting the MCP and you're working with these things, as you're seeing what tNav is doing, sorry, what Claude, the agent is doing, you can ask it to, okay, this is important to me. Please highlight everything that you're doing, document it, any assumptions, any extra steps that you've taken, show them to me in a particular report. So Yeah, let me just see very quickly, just make sure that it all works. So we've got some new perforations for the new wells. And we've got, as we've asked it, we actually have a restart model. So let's
Yeah,
see if we can make this work. Yeah, yeah, that's a valid restart that I can then run my model. So updated model, just asking it plain English. Something that would have taken me, for consolidating all those changing units, I would have probably gotten it wrong, to be honest. Particularly when there's like lots of things to put together and units to convert. It just becomes a bit of a mess. So in that sense, I'd say AI is a bit more secure than a human for these things that you need endurance rather than knowledge. So
absolutely.
when you need to do lots of things.
These were a couple of great examples to open the appetite, and this is just about experimenting with this.
Mhm,
So much potential and so many use cases I can think of. Before I let you go, just one question. Can you explain again, man? I mean, obviously you're working with a public data set. This is the Volve field.
mhm,
If I were to be working with a field of my own, a project, files of my own in a company infrastructure, every time you prompt, these things go out to Anthropic servers. So there will be a security concern. So can you repeat what you said? What are your guardrails, protections, strategies when you work on your own data?
mhm. First, clarification. So not everything goes to the Anthropic service. It's essentially uh, it's only what you feed the Claude code, so the prompt, and then any files that it needs to touch.
Yeah,
So let's say you need to do some data processing like we did here. You have lots of data, then you actually need to, you ask Claude to make sense of this data so that it can format it correctly. In that case, because it touches those files, because it reads those files, then yes, that data does go into the Anthropic servers. If you do something that doesn't touch the files, if you describe the problem yourself and you say, I have this file with these columns, make me a Python script that puts from this format with these columns to this format with these columns, then that no data will no private data will go to the server. So that's the first thing, and that's usually the sort of the one line that it's important to kind of highlight, just because there's a little bit of sometimes confusion as to what goes and what doesn't. And in essence, it's just what you feed it and also which files it touches. So the thing that is useful to do is you make essentially a dummy file,
yeah,
or you use public data sets. So you have a public data set that has the same format. I'm just using this as an example of the formatting stuff. So you have a public data set that has the same format as to what your actual data that you're trying to convert. Then you tell it to do the exercise or the task on the dummy data set that you have, or in the public data set that you have. And it will go and create scripts and create tools to handle that data. And in that case, that data will touch the service. But once it creates those scripts, once it knows what to do, then you can tell it, okay, in this case, you don't need it to analyze the data. You need to go into those files. You can either yourself run those Python scripts or those scripts that it would have created manually using the terminal or using command prompt or using whatever you use to run your code. So in that case, it's fully self-contained, and you're doing manually. It's obviously you need to do the button pushing for those
sure.
codes, but then you rest assured nothing is leaving. The other thing that you can do is you can tell Claude, you can let the agent do it for you. You got to be careful with that sort of stuff as well, if it's super sensitive data, obviously. But you can tell it, look, you have this script. I don't want you to read my data. All I want is to run this script on this file. And it just runs the script on the file, and no data should in theory, go into the service. The other method that I was mentioning would be to use one of those enterprise versions of the software, in which case Anthropic or whichever company is the developer of the agent that you're using, essentially pledges or says that yeah the data is not used to train their systems and it's not public.
Yeah, the data still goes out in those enterprise offerings, though. So unless you really deploy locally your models and stuff, you're still. I mean, again, people do not really understand the details of this stuff, so they just get concerned at the door,
Mm-hmm.
uh, even if a chunk goes out. But in this specific example, where you asked to update your production history
Mm-hmm.
from a bunch of files, that is a very specific case with those files you had available for that stuff. So it's difficult to think that that can be just scripted out and then apply the same scripting into a real case, which will have a different suite of files, perhaps with a different format and all that stuff. So
Mm-hmm.
some examples for sure, you can do it on a template with fake data, dummy data, or synthetic data sets, or
Mm-hmm.
public data sets, and then just apply those workflows and scripts on yours. But sometimes there's no really other way around actually working on your data. And again, either you assume the cost of knowing that some of this stuff will go out to external servers, or simply just need to implement your local infrastructure with local models.
I think the other thing as well, which might be kind of a compromise or a world between them two, is there's lots of tools. TNAV has a few as well, where you can anonymize particular things. So you can go to a model and ask it to anonymize it, and it removes all information about coordinates.
Yeah,
It obviously retains the well trajectories with the reference of a 000 base coordinate. So it doesn't have any idea of where the location that field might be. It changes well names, and it changes pretty much any data that could kind of connect it to a particular asset or field. So those sort of tools can be useful and can be a compromise. So you can still work with your data. It's just data that's been anonymized. So you essentially need to manually anonymize it, or a tool that can anonymize that data. And then you could, if if it's you're accepting of that of anonymized data leaving the premise, that could be a potential solution for it as
yeah.
well.
No, that's a good one. Yeah, a few options there, but
Hmm.
again, man, that shouldn't be a reason not to leverage these tools. This is amazing power, and again, the examples you showed are just a teaser for the extreme capability potential increase here.
Just before we wrap
So
up, I wanted to show you just a couple of other, just the examples that I was thinking about.
yeah,
It's a few um, things that I've gathered just from working with other people and seeing kind of what could be useful. So just to give ideas to your audience as to what they could try in this sort of thing. So the third, which is the one that I'm running here, we're not going to wait for it to finish, but just in case it does generate something for us that we can just wrap up with, I'll leave it running. But the third example is a lot of times you've got a model, you run it, and then it's a matter of someone's asking for a report on the
yeah,
model. So you just want to, it's usually, you know what you want, you have a structure, so you have a template, and you have a company sort of branding. So I'm just telling Claude, look, here's my template, here's my style guide, use that and create a report for me. A lot of times it's a lot about copy pasting
yeah,
screenshots and stuff like that. So it can take a bit of time, it can be tedious. You can use this to automate, and I have this to automate graphs for all wells across my
yeah.
model, put them all in a report, something that I don't want to be clicking through, just put them out. So that's I find pretty useful.
Yeah, and just to add to that, because obviously you are connecting to your own specific computer and a specific folder, you can have
Hmm.
actual files there in the format you want. You can have PowerPoint files, you can have Excel files, and you can tell Claude to open those files or use those templates and fill those. So it doesn't need to be necessarily just Markdown files or
Hmm.
PDFs. It can also interface with your very own Excel files and PowerPoint templates.
That's right. That's right. That's just like it's super cool. So in this case, style guide that I feed it was actually from a letterhead that we had for RFD, which was in what do you call it, Word. So I grabbed that, it created a style guide from that, and it refers to that report as well, using the footnotes and whatnot. So yeah, so you're right. You can connect it to all your other types of files, formats, and stuff that you see through. I have another example here, which was like sometimes someone hands you a deck which has like the full thing in the data deck is not split into include files and whatnot. It's a bit of a pain to work with, and you have to go manually sort of select and do it. So you can ask it to clean something for you. So you have a very messy data deck, actually split it into include files and highlight any things that might be. One of the things that sometimes catches people is like units. Sometimes one thing when someone was building the model, they didn't pay attention. Things were imported in a different unit set, and nobody really realized. You can tell it to kind of check through those things and make a sense check of unit systems, for example, fluid densities and stuff like that, that can throw things out quite significantly. Just okay, just have a look at the numbers and see if they make sense before I go into this sort of model. You can use it to use mass edits to like rename. If you have fields with hundreds of wells and you have a new naming convention, tell it to run that for you. To do a QC sweep, like I said before, so units and whatnot. To do history matching, so it's like kind of the next tier that I mentioned before about pattern recognition and seeing how we can sort of change things that you might have missed as an engineer. So to analyze the data, tell you what you could try next, and then you try it, because it's important for the engineer to do it. The whole thing I'm trying to drive here is yeah, it can be flashy to set Claude to do stuff for the engineer, but it's not really useful. The useful stuff is taking the menial part of your work,
100%.
the cool stuff. Is up to you. The decision,
100%, man.
that's important stuff. So yeah, lots of other examples, but it's the world is your oyster essentially, and
Absolutely.
it's a
Absolutely.
really cool
This
space to
is
explore.
what a playground this is, man. Absolutely fantastic. Well, I took an hour and a half of your time, and I really appreciate you coming on.
No worries.
This is a great appetizer, and people need to go and get their hands dirty playing with this stuff. So much potential here.
It's good
Uh,
fun.
just on the licensing side, just to clarify, this is a separate license altogether. The MCP license is what's needed.
Correct. Yeah, it's a MCP license server. If you're interested on giving it a play, we can have a chat to us, and we can definitely get you up and started.
Best support team in the world, man.
Thanks. Appreciate that.
All right, Andres. Thank you again, man, for coming
Thanks
on.
very much,
This was
Alan.
awesome. Talk
Appreciate it.
soon, mate.
Talk soon. Have
Have
a
a
good
good
one.
one.